Hello and welcome, lazy chemists, to today's lecture, which is going to be on the topic of lazy ionic bonding. Okay, so we're going to go over ionic bonding. We're going to show how to show those things in a formula, and then we're going to go ahead and show you guys the shortcut methods that we can use to easily solve some of these problems here. So the first thing that we're going to want to do is to define ionic bonding. And ionic bonding is going to be a bond between a metal and a non-metal. Okay? And what's going to happen here is that this is going to involve a transfer of electrons from the metal to the non-metal. Okay? So now some of you may be asking, all right, now we have our definition here, but what is a non-metal? And if you go to P-table actually has a way for us to go ahead and easily see it here. And here, we can go ahead and highlight metals, and all of the colored ones that we have right here are metals, which means that back in our definition that these are going to be the things that lose electrons. Okay? We can go back here and look at nonmetals, and nonmetals are going to be the things that can take electrons. Okay? So notice the nonmetals here, they're very small. It's only got this small little area where we've got like the carbon, the nitrogen, oxygen, and fluorine. And then the metals make up a majority of it. Okay? So, let's go ahead and start by making an example here. Alright, so let's say that we have a metal, and let's go ahead and have it be magnesium. And for some reason, I want to go ahead and have magnesium right here. And we'll go ahead and draw a magnesium atom. Okay. Alright. Now, magnesium has 2 electrons on its outer shell. Okay. So we're going to go ahead and draw the outer shell electrons, and we'll draw them all nice and big. And we'll say that magnesium's electrons are blue. Okay? And let's say that along comes another atom, and let's say that this is a fluorine atom. Okay? So we'll go ahead and draw fluorine. Okay? Now, fluorine is kind of a bully, alright? Fluorine has a total of 7 electrons in its outer shell. Okay, and we're going to go red. 1, 2, 3, 4, 5, 6, 7. Okay, so fluorine has a total of 7 electrons in its outer shell. And when fluorine meets magnesium, it's going to go ahead and take magnesium's electron. Okay, it's just going to take it. And now that fluorine has 8 electrons in its outer shell, it's going to be happy and full. Okay, so let's go ahead and get rid of that first one from magnesium. Okay. So the blue one from magnesium got transferred over here. Now this magnesium, it's going to be very, very reactive, and it's going to be kind of upset that it's lost its electron, which means that it's going to be easy picking for another fluorine to go ahead and come along and take its electron. So we'll go ahead and draw a second fluorine here. Okay, and this second fluorine will go ahead and take the last electron from magnesium. And I know that we've been anthropomorphizing our elements a little bit here. But this is essentially what happens. You actually have an element like magnesium, where it's a metal, and two nonmetals will go ahead and come along, they'll react with it, and they're going to steal that electron. Now, each fluorine has taken one extra electron, okay? Because they've each taken an extra electron, they have a charge of +1, or they have +1 electron, which means that they're going to have a -1 charge. Okay? So both these fluorines have a -1 charge. This magnesium has lost 2 electrons. Therefore, this magnesium is going to have a +2 charge. Alright? Now, at this point, we have magnesium and 2 fluorine. Both of them have charges. And what's going to happen is that we're going to have a bond here, because this negative fluorine is going to be attracted to this positive magnesium. Okay? And this is what forms in our ionic bond. Okay. From here, we can also go ahead and write our formula. And the formula states, hey, we have 1 magnesium and we have 2 fluorines. Okay? And because chemists don't like to write the number 1, we're going to go ahead and omit the 1. Okay? So we're going to have MgF2. And this is kind of our representation about what's going on with an ionic bond. Now, what's going to happen is that an ionic bond, in terms of the metal, an ionic bond is always going to take away the valence electrons from a metal. So anytime we have an ionic bond, all that can be lost are the valence electrons that are in the metal. Anytime that we have an ionic bond, we're also going to fill up the last valence electron shell for the nonmetal. So we'll go ahead and say that we'll fill up the valence shell . Okay. So that means that our metal is going to end up having 0 electrons in its valence shell. And then our nonmetal will have 8. Now, in general, for chemistry, there are going to be times that, the official way is to go ahead and draw it out like something like this. However, that's not really the lazy way. The lazy way would be to go ahead and figure out how many valence electrons a metal is going to have beforehand, and then just switch it and do kind of like a ratio switch, which is what we often want to do in a chemical formula. Okay, so what we're going to do is we're going to go ahead and do one right here where it's going to be aluminium oxide. Okay, and we're going to go ahead and figure out the formula for it. And we're going to figure it out the lazy way, okay? Because we don't want to have to draw out aluminum atoms and oxygen atoms. That takes way too long, okay? So what we're going to do here first is we're going to go ahead and find aluminium on the periodic table, okay? And aluminium is right here, all right? And what we're going to do is we're now going to go ahead and count. Remember how I told you that you guys were going to have to count in this section? Well, it's time to put all your kindergarten and first grade math skills to use, okay? We're going to count from the first row. We're going to count this as 1, because all these metals lose 1. Kind of count this as 2, because this one has 2 valence electrons in its outer shell. Then we're going to skip these, and we'll have a lecture specifically on these for tomorrow. And then 3, 4, 5, and 6. Aluminum is 1, 2, 3. Okay? So that means that aluminum has 3 electrons. And it says that aluminum will lose all of its valence shell, okay? And it has 3 in its valence shell, which means that aluminum will be plus 3. Then we have to figure out oxide. Well, the oxide looks like it's oxygen, okay? So we look at oxygen here, and oxygen has 1, 2, 3, 4, 5, 6. Okay? From our rule that we stated earlier, it said that the nonmetal will have 8 electrons in its valence shell, and right now oxygen only has 6. So that means that it's going to need to get 2 more. Okay? So we'll put 2 minus there for oxygen. Alright? Now we're going to have to figure out how to put these together. And what we could theoretically do is we could theoretically figure out the ratio that these would multiply by in order to get them to be the same. So we could theoretically multiply this one by 2 and then this one by 3, and then we could, see that, we have 6 electrons and 6. And then that would be 6 plus, and then 6 minus. And our goal always is to make it so that we always have the same amount of electrons, so the amount of electrons lost has to be the same gained, and that would equal 0. But chemists have an even lazier way. So our lazy way here will be to go ahead and just be like, oh, okay, well, Al, and that's 3 plus. And that's being added to the oxygen, that's 2 minus. Well, let's go ahead and just take our number, and we'll crisscross them. So Al 2O3. And then the last thing we have to do is we just have to make sure that it's all in lowest terms, okay? 2 and 3 don't divide into each other, so we're good, all right? And that's how we figure out the formula, okay? This is like the official way of doing math, and this right here, this is the lazy way. So if you don't like math, this is the way that you want to go. You just want to crisscross. Now let's go ahead and start with another example here. We'll go ahead and do rubidium fluoride. Okay? So we're going to have to find rubidium and fluoride. So we look over here, and we look, and we look, and we look, and we see, right here. Right here. It's in the first column, rubidium. So since rubidium's in the first column, we're going to go ahead and put +1, because it's in the first column. And let's go ahead and also find fluoride here. And look, it's right there. And fluoride is in 1, 2, 3, 4, 5, 6, 7. Okay. So, rubidium here, that's going to be Rb. And we said that that's a metal, and it's in the first column, so that's +1. Fluorine, that one was in the 7th column, but it's a nonmetal, so that will be -1. So, we'll go ahead and take our numbers here. We'll take this one, this -1, we'll move it to rubidium. The positive will move to fluorine, and we'll have R, B, F. And each one of these would have 1 and 1. But chemists, we have a natural fear of 1, so we're going to go ahead and get rid of it. And we'll write it as R, B, F. Alright. The next one that we're going to do is going to be calcium sulfide. Okay, so we're going to do calcium sulfide next. So we'll go ahead and find calcium first. And calcium is right here, it's in the 2nd row. So calcium 2nd row, it's a metal, that means that it's going to lose 2. And then sulfide, we'll have to find sulfide here. So that's right here, that's sulfur. And sulfur is in 1, 2, 3, 4, 5, 6. So it's 6, and it's in the non-metal group. So that means it's going to gain 2 electrons. Okay. And we'll go ahead and do the same process. We're going to go ahead and take this one. We're going to move it over here. This one will move over here. Look at Ca2, S2. But notice that this is not in our common terms. This isn't in lowest terms, okay? Because we got 2 and 2. Well, can you divide 2 and 2 together? Yeah. So therefore, we'll go ahead and put it down into lowest terms. Ca1, S1, and then we don't like 1, so we'll have Cas. Okay? And that's how we do our writing of formulas. Now I want you to note a couple of things. First of all, each and every one of these compounds that we did, I want you to notice that the first element that came up, even here with magnesium, was a metal. So every single time that we have an element, a compound, we're going to start with the metal. The non-metal is always going to be the second thing in the name, okay? And so it'll also be the second thing in our formula. So just take note of that as we go forward here, okay? I'm hoping that this new review and the new lazy way should help some of you re-grasp this. You should be able to work on your new assignment for this section, which is really just practicing this some more. Okay? I hope you all are having a nice day, and remember, be lazy.